So yeah, I did win a few stick games, but I lost many more than I won. But I am now a stick. I should get a badge for that or something. Like after you win 25 games. So so yeah, PA2 is in the books, and I've graded that and I've given you some feedback, and I'll talk about some of the specific feedback um, today. But by and large, right, PA2 looked really good. If you thought that you had done a good job, you probably did a good job because you could see sample code and you knew what it was supposed to do. If you weren't satisfied with your code, hopefully you had already written to me and we talked about it. But let me point out something up front, which is you know these programming assignments are not something that you're turning in as part of your job and you're going to get fired if they don't work right or something, right? They're really just part of the learning, um, and they form a component of your course grade. But the real goal in these assignments is to learn, which means that for most people the assignments will be something that you haven't already done, and but hopefully something that you know how to do or you can figure out how to do. And to whatever degree that happens, that's all good. That's getting out of the assignment what you want to get out of it. And if you don't feel like you get all the way to where you understand everything that you did, or you had things working exactly the way you wanted, right? That's stuff that we should talk about in office, or to whatever degree is reasonable, in class if it's like general issues. And the goal is, that after PA2 is all said and done, we've talked about it, that you know how to do the things that you had to learn for PA2, and then we can build on that as we go on. And then at the end of the course, you've learned, this chunk of material that makes up 224, and you build on that when you go through CSE222, and you build on that for 223, and then you build on all of that when you transfer to your university, and that's how this is supposed to go. So if you spent a lot of time on PA2, that's not a bad thing. That's a really good thing. Um, and if you ran into some problems that took you a really long time to fix, but you got them fixed, that's obviously really good. Even if you couldn't get them fixed, if you felt like you were making progress, even if it's sort of lateral progress, you trade off one error for another, right? All that stuff is good learning experience. Let's just touch base, in office, and make sure that you can like dot the i's, cross the t's, um, or go through major things that are being misunderstood or aren't there. But by and large, most of the games worked well. The main deductions that I saw for people were in the matter of error handling. So having issues with how the number of sticks was specified, being able to take that number from the command line or at runtime, that kind of thing. Um, and it may have been some degree of not understanding the requirements, but most of the time when I saw those issues and I dug into the code, it was using scanf instead of scanf, not checking the return value from scanf. I think everybody checked argc before they used argv, which is great. That's a hard battle to get through, but I think everybody was doing that, which is awesome. Um, but not scanning for the extra stuff, or not checking the return value from argv, from scanf, or not doing the right thing with it.
On mine, you said you had some issues with getting input, but I wasn't precisely sure what you meant by that.
So come by office hours. We can go through your code in particular. Do you remember exactly what the wording was?
Uh, it was many issues with picking an extra number of steps activity.
Okay. So let's look at some some examples. So let me show you some of the tests that I ran. So some things that I tried. Putting in too many arguments on the command line, right? That should always throw an error. Putting in an argument that's not a valid integer. Putting in something that's not even close to a valid integer. Putting in something that's too small. If you just say stick, then it should ask you how many sticks do you want to play with. Putting in something that's not a valid integer, even if it starts to look like a valid integer. Putting in something that's blatantly not an integer. Putting in nothing at all. Putting in something that's too small. All of those, right, something's wrong, goodbye. And then if you say stick and you put in a number, it should play with that many sticks. If you say stick and you put in a number, it should play with that many sticks. So if there was like one minor error in some of this stuff, then I might have said, you know, some errors. If there were multiple errors, then that was the message that you saw.
I see the issue. We slip past. You could put in this string and it would just start decaying zeros.
Okay. All right. No problem. So if the number of sticks was able to be specified correctly, then you get to here. So one thing I tried was just winning the game, right, and make sure that I won. Another thing I tried was losing the game and make sure that it's always picking a number so that I end up with a multiple of 4 sticks and then it ends up losing. And then trying some goofy input for the number of sticks to take. So putting in nothing at all, putting in illegal numbers, putting in things like that. And then making sure it continues to play and wins. And then looking at the source code, looking for commenting, indenting, things like that. So those were the basic tests that I ran. And depending on, you know, if everything worked great for those, then that was pretty much it for testing. And I went on to looking at the code. If there were issues with that, then I dug deeper and tried more variations. Yeah.
But it didn't say in PA2 to do that, so I'm kind of curious if the intent was for us to do that.
Picture of the sticks with the number of sticks in parentheses. PA2 is exactly PA1 except for those changes that were noted in the beginning.
Okay, so I didn't understand that. Because it wasn't in the instructions in PA2. Okay.
Okay. So yeah, so a number of people seem to forget a lot about PA1. And I didn't always take off points for this, but let's talk about some of the things I saw. So the first is your code has to be commented, right? You got to have comments throughout your code. I did not explicitly say in PA2 you will lose points if you don't comment your code, but from here on out, just take that as explicit for every assignment that you turn in for me to grade. ODPs you don't have to comment because I don't look at those, but anything you turn in here or any of your other courses, for me, you got to have comments in your code. And they've got to be, you know, throughout your code. Whenever there's anything that's not completely obvious, why am I subtracting numsticks %4 from numsticks? That's not obvious. Put in a comment. Say what's going on there. You got to have comments in the beginning. You got to have your name in the beginning. About half of the assignments didn't have the name of the person who wrote the code, right? If you do a painting, you're going to sign your name to it, right? If you write a story, you're going to put your name on the title sheet. Same thing with code. Always put your name in there. Unless, you know, you're working at a company and they say, don't put your name in your code. Okay, fine, whatever. But for here, definitely, you know, you want credit for all the hard work you're doing, put your name in the beginning. And for assignments you're turning in for class, you know, put in your name, the date, the assignment, a synopsis of the program in your own words, all that kind of stuff. I'll try to mention that in the assignments going forward, but if I don't, right, take that as a standing requirement. You also need to indent your code in some consistent way, right? So I don't care, you know, if you indent before or after the curly bracket. I don't care if you indent 2 or 4 or 3 or a tab or what, but you need some kind of consistent indenting style. let's see. So a couple of minor math issues here and there. A couple of issues with announcing who would win the game, where the user would win, but the computer would still say, "I won," you know. So minor things like that, and that's just checking flags sometimes. The initialization stuff and the stick picking stuff that we looked at here, basically checking that. And like I say, those are the main things where points got lost. Seg faults cost points.
They weren't in the instructions, and I apologize for that.
Oh, that's okay. Alright, seg faults cost you points. A lot of courses, seg faults get you an automatic 0. I didn't do that on this one, but later, as we start working with things where we expect seg faults to happen more, seg faults will be more and more critical to avoid. So don't seg fault. If your code did not compile, I tried to work with it. I either looked at the code and tried to sort of figure out, just from looking at the code, how close you were, how much of the game you had working, or in some cases I made a copy and tried to fix, if I saw like one main compile issue, tried to fix that so I could go ahead and grade. But generally, if you can't compile the code, it's really hard to grade. If you get a bunch of warnings, you got to fix those too. If you got one stray warning here or there, I let it go this time, but you never want any compile warnings or errors. So make sure you dig into those. And I think that was it for the main things that I saw. And like I say, feel free to come by office and we can talk about specifics. I can show you particular test cases if I didn't list them in the comments for things I was seeing. Alright, go ahead and let me know you're here. Send me an attendance note. And let's see. Which programs do you recommend for midterm exams? Microsoft Word seems to be a not good option since it is not a coding program or something. I downloaded Notepad++, but it doesn't save as PDF. Notepad++, you should be able to print to a PDF. If you try to print, Microsoft should have a Microsoft Save to PDF option when you say print. Please don't do screenshots for submitting code though, because if those aren't totally perfectly crystal clear to read, it's going to be a hard time. But yeah, try Notepad++ and use save as, or print to PDF. What else can you use? If you're good with Word, you should be able to put it into some kind of pre-formatted mode where it doesn't change your formatting, but that's always hard. Someone says try VSC, which I haven't tried, but you could look at that. Oh, Visual Studio Code. But make sure it's not doing any code completion for you. Someone used JGraphs, someone says Atom. And if you've got a Linux setup, right, then you know, take your pick. Alright, so let's talk a little bit more about the midterm, which is on Friday. So again, the midterm is during class time. It's Friday from 10 o'clock to 10:50. If you have an extended time allowance, just take the extended time. The midterm will be a PDF that you download from Canvas, which will be available at 10 o'clock, and you'll need to upload it by 10:50 or, you know, by whatever your extended time works out to. Canvas will accept uploads forever, right? But it's going to cost you 10 points per minute if you upload late. So don't upload late. Okay, Canvas won't check that, but it will turn out to be 10 points per minute according to Canvas's declaration of how late it is. So if you turn it in 5 seconds late, you're down 10 points. So don't turn it in at the last minute, right? Give yourself, you know, a minute at the end to do the upload. And you know, make sure that you practice ahead of time whatever tool you're going to use, writing your code and saving it as a PDF. And then upload those PDFs. You can upload multiple times, right? So don't make your first upload at 10:49 in 30 seconds, right? You finish a program, save it as a PDF, upload it. But have that down so that that doesn't take you 5 minutes to do, right? Know what directory it's going to save your file into. Have that folder already open on your desktop, right? Have the Canvas page already open with the upload option. Think efficiency, right? Plan this out ahead of time, because you don't want to lose time trying to upload or trying to format or trying to find a file that got printed or things like that. It's not ideal. It's part of the kind of online reality we have, but you can make it, you know, pretty unobtrusive if you sort of plan ahead of time. The midterm will probably be having you write a bunch of code, right? Some of it will be, you know, write a function to do this. Some will say write a bash script to do this. Some will say show me a few lines of bash code to do such and such. So basically, go back through all the programming you've done. If you want to prepare for this, go back through the ODPs, go back through the programming assignments, and expand on them in your head, right? If you're not totally clear on the argc argv thing, practice with it. Write yourself a program that takes 2 command line arguments and adds them together and prints them out, right? And you know, you're gonna have to use argc and argv and scanf and all that kind of stuff. So practice all that stuff. I don't know if it's going to be balanced between C and Bash. I'm thinking it probably will, but I haven't even started thinking about details for the exam yet, so I don't know. Well, we've had one assignment in each, and so on. What else can I tell you about the midterm? Pace yourself. Make sure you only do what I'm asking for. If I say, you know, show me a few lines of bash that would take the variables x and y and print out their sum, don't make a whole script, you know. Just write a few lines of bash. I recommend strongly that you be in the Zoom room during the exam, because, you know, almost guaranteed I'll make some mistake when I write the exam, and I'll do something that doesn't make sense, or I'll you know, ask you to do something that's not complete, and somebody will ping me and say, hey, what did you mean by this? I'll announce it in class if there's changes or clarifications like that. If you're not in Zoom, you don't hear that, and you might end up spending 30 minutes trying to do something that can't be done, right? So I recommend staying in Zoom. I'll keep my microphone off, but just keep it so that you get a ping if I post something or say something. Yeah, Bash feels like a long time ago sometimes, and you know, it's similar to C, but it's different. So definitely go back and review, you know, maybe your stick game from PA1 and the earlier ODPs. If you've been taking notes throughout the course, if you've been, you know, synopsizing what we do each day in a set of notes, then you've got notes to work from, right? You have the textbook, but the textbook is really big. You have, you know, hours of videos, but you don't want to try to go through all of those this week. So hopefully you've got notes that you can use. The exam is open book, open note, open access to any code that you've written, but that's it, right? So no online sources, and you know, obviously no chatting with people and so on. All right, any other questions or thoughts or concerns on the midterm?
So don't write a script unless explicitly told to do so.
Yeah, I'll be explicit on what exactly each question is asking for, and if there's any confusion, go ahead and ask for clarification. and if you've prearranged with me the first week of the term to take the exam some other time, that's fine. But other than that, you're expected to take it Friday at 10 o'clock. All right. Anything else? So I'm still working with some people on PA2, but let's I don't know if I commented my code or not. This is going to be embarrassing. Um, but my version of stick. Hey, I added some comments. Um, this is a way to do this stick picking game. Um, and most of this is stuff that we've talked about already, over the past week or two, right? So prototyping functions, and I went ahead with an init function that would process the command line arguments for me. And my main program is a little bit on the long side here, right? So I print out a welcome message. So these are just instructions, and then I call init to process the number of sticks. And this will, take the number of sticks from the command line, or it will ask the user while the program's running, and it will do the syntax handling and so on and so forth. And this init function just returns num sticks. It's number of sticks to play with. If anything goes wrong, it gives me back a 0. So after I call init, I can say if num sticks is 0, return, game's over. Otherwise, I went ahead and printed out the initial pile of sticks. You didn't have to do that. And I set a flag that I don't think I actually use, maybe I do, to say that the game is going on, and I say, well, the game is going on. And then this is the pair of turns. So CPU turn, I call CPU move, I tell it how many sticks to play with in the total pile, and I get back an integer, which is how many sticks the computer's taking. I print out a message, computer takes %d sticks or stick. So this is just putting the S on the end of sticks if CPU takes is not 1. So that's just a thing. And then I subtract that from the number of sticks in the pile to get a new num sticks. If the resulting pile is 0, I say, hey, you've lost, and I return. So I exit out of the main program. Otherwise, the game is still going, so print out the number of sticks in the pile, and now it's the user's move. So I call getMove to get the number of sticks the user wants, and that handles all of the error handling, the retrying, and so on. Subtract that from the number of sticks, and then if the number of sticks left is less than or equal to 0, I say you won, and I exit. Otherwise, print the pile of sticks and go back. So this is the main game loop. But all of the preamble is mostly handled in this function call up here, init. And then the game loop doesn't have any of the logic, it doesn't have any of the error checking, it's really just take a turn, adjust the pile, see if the game's over. Show me what this game state is. Take a turn, adjust the pile, see if the game's over, show me what the number of sticks is.
Did we get marked down if we didn't adapt certain functions of the code to Boolean methods, or functions?
There was no requirement to use any functions at all other than a main function. You're welcome to have done it in one big main program with all the code in there. That's fine. But going forward, it's going to get easier and easier if we think about breaking these things down into pieces. All right, and then the rest is just support functions. So print sticks is a for loop. Print out that many sticks. Print the number in parentheses. Get the user moved. So this is stuff we're all sick of seeing at this point, right? So prompt the user, do an fgets to get their input. Do an scanf on their input using this trick to convert an integer and extra stuff. And if this scanf returns 1, we're good, right? So if the return value is not 1, that's a problem. If the return value is 1, but the number is less than 1 or bigger than 3, that's a problem. So if we don't like their input, we say, how many sticks do you want to take? Get the number, scan it again. So this loop will run forever until the inverse of this statement is true while run De Morgan. It means return value equals 1 and number is bigger than or equal to 1 and number is less than or equal to 3. So once we get a valid response, we return that. Sorry?
Out of curiosity, how many or statements can we have in a while loop?
Many as you want.
Oh my goodness.
Yeah, I mean there's a theoretical limit, but nothing we would be likely to hit.
Noted.
Yeah, C and most languages actually will sort of let you do more or less anything. I mean, you can nest, if statements inside whiles, inside fors, inside ifs, inside elses, and, it will do whatever you tell it. The programmer will get confused long before the CPU, usually. CPU move is straightforward because there's no error checking, so just take the number of sticks mod 4. I save that in a red val. If it's equal to 0, I change it to 1 and then just return that. And then the initialization is all of those checks that we've been talking about, right? So first thing, check argc. If it's bigger than 2, that's an error. You need to either say stick or stick followed by 1 argument. So if argc is bigger than 2, that's an outright error. We're done. If argc is exactly 2, then you said stick space some number. So then we scan that argument, which should have the number, using our scanf trick. And if the return value from scanf is 1, meaning it found exactly an integer, and that number is bigger than or equal to 20, we're good to go, just return that. Otherwise, they said stick space something, and the something was bad. Print an error message, return 0 as a flag. So this is too many arguments, argc bigger than 2. This is 1 argument, argc equals 2. The only other option is they had no arguments. So this stuff down here is where they just said stick. And so now we prompt them as the program's running how many sticks, do a gets, do the same parse. If the parse returns exactly 1 and the number is valid, then we return it. Otherwise, something's wrong and we return 0. So there's other ways you could have done this, obviously. There's other ways that you could break it into functions. There's other degrees of granularity that you could use. But that's one approach to it. And comment-wise, I mean, this is a lot of things to OR together in a while statement. It's worth, putting a little note here saying, hey, this condition is basically saying we need to try again. I don't need a comment here which says, ask the user how many sticks. I don't need a comment here which says read the number of sticks. I don't need a comment here which says scan the number of sticks, right? Those things are pretty clear, but the fact that this whole thing is in a while loop, that might be something that's not as obvious, right? So I have a little comment up here. I got the sun going behind me again. And then when I move from one section of code to another, I like to have some comment there to tell me what's going on. So, the purpose of this is ask the user how many sticks they want to take. Here's my initial attempt to get that number from the user. And it should return a 1 and the number should be in range. So that's what's going on here, is we're making sure this condition is satisfied. When we get down here, we've got a valid response and it's a valid integer. And then we go ahead and return. So find a level and style of commenting that makes sense to you, but make sure you're doing something, right, as far as comments. All right, any other questions, comments about this? All right. This is probably a good point to talk about some VI. And we're in week 5 out of an 11-week term, so we're coming up on the halfway point We're going to keep working in C. Your third assignment will be another C program. Your fourth one will go back to Bash. And we're going to keep working in C. We're going to start working more with strings tomorrow. Oh, let me talk about the ODP first, because the ODP is up. And then we'll talk about VI. So 413. Yeah, let's talk about this first. All right, so 413, you're writing a function. Okay, it's called count E. What it does is count the number of E's in a string. So if I, for example, call count E hello there, this should return the number 3. So if I say integer I equals this and I print I, it should print out a 3. Because there's an E there, there's an E there, there's an E there. So count E is let me move this somewhere else. Count E is a function. It takes a char star, which is a string, and returns an int. Alright? So that string that it gets is basically an array of characters. And you make a loop that goes through that array, character by character, checks each one to see if it's the letter E, and if it is, adds 1 to a running sum. And then when you're done, if you've hit the end of the string, you just return that sum. That'll tell you how many E's you had. So we'll talk about that detail-wise in a minute. But from a higher level, right? Write this function, test it with your own test code. You can do things like this, right? Just call count E parentheses quote and pass in a string and print out the value that it returns. And if this is your string, it should be, you know, I. If it's you know, A, B, C, D, E, it should return a 1. If it's A, B, C, it should return a 0. If your string is empty, it should return a 0. If you call count E with just an empty string, that should return a 0. So write a main program to test this and convince yourself it works, and then link it in with a test bed, ODP 413 main.o, and assess it. And you should get 10 out of 10 on each test.
Isn't there a way to like take a string input and then like cast it like in an array and then go through each I forget what each part of an array is.
So an array, right, has individual elements. You can access them with square brackets, and a plain old for loop will let you go through element by element. And that's what you want to do here. Don't try to do fancy things like regular expressions and that kind of stuff. So let's look at an algorithm for doing this. So strings in C are just an array. So let's pretend we have a function called count E. I'll just call this input. So input's the string that we're trying to analyze to determine how many E's are in there. So main way we can do this is, you know, have a running total, which just means the variable we're going to initialize to 0, and we're going to increment each time that we find an E. And then for each character in input, if it's equal to an E, then num equals num plus 1. And then return num. So that's kind of the pseudocode version of how you can write this function. Initialize some kind of counter to 0, loop through each character of input, and if it's equal to the character E, and we need single quotes here for characters, if it's equal to the single character E, then increment your number. So we use a single quote for chars, and we use a double quote for strings. Strings meaning an array of characters. So how do we do this business of for each character in your input? So we gotta be able to do two things. We've got to know how many times we should loop. In other words, how many characters there are in the string, and we need a way to access each element in that string. So how do we know how many characters a string contains? Anybody remember this?
Was it like a length command or a function?
Mm-hmm. Anyone remember what it's called?
I think my brain's thinking just length, just the function called length. So I might be completely wrong.
You use sizeof, and then size of the size of each size of a single divided by the size of the single element, right?
All right. So thank you for bringing that up. Let's avoid sizeof. Sizeof causes way more trouble than it should. And let me
It's exclusive to GCC, right?
well, it's part of the standard C language. But let me show you what can happen. Alright, so if I set up temp to be 120 characters and I say print out the size of temp, didn't have enough O's. So I'm going to get an error here. But it's going to tell me size of is 120, which feels like it's doing the right thing, right? But if I pass this thing a string, it's going to tell, oh, that's a bummer. My cautionary tale has been foiled. Should have done this ahead of time. Alright, so I'm going to print out argv bracket 1 as a %s, and I'm going to print out size of argv bracket 1. This is actually good. So if I say oops hello, it tells me argv bracket 1 is hello, but size of returns 8. If I do oops a, argv bracket 1 is a, size of returns 8. If I do oops with a really big long string, tells me argv bracket 1 is a big long string, size of returns 8. So the problem here is size of is not meant to work on variables, it's meant to work on variable types. And if your variable is declared to be something like character bracket 120, it will say, oh, that's an array of 120 characters, it'll return 120. But if your variable is a pointer to a character, which is also an array, it doesn't know how big the array is. And so here's an example where, I've got a string that I'm passing in as argv bracket 1, But sizeof is not telling me how many characters are in there, right? It can't, because arrays don't have any inherent length. So if we want to know how many characters are in there, we want to use a different function, which is string length. So almost length, but strlen. So let's return string length of arg bracket 1. So there's oops, and string length returns 105. There it returns 3. There it returns 1. The danger with sizeof is it works, about 3/4 of the time, and it fails when I'm grading your program. And so it's just really it's tricky to use right. There's cases, particularly in 222, where we're gonna have to use string length or sizeof, but for now let's avoid it. You can also loop until you get to the null terminator. That will work too. But I'm going to avoid that for this discussion. But that's exactly what string length is doing. It's looping for the null terminator. So yeah, we want to use string length to know how many characters are in this string. And so if we know that, we can do something like, for I equals 0, I less than string length of whatever, I plus plus. And now we can say if, whatever our array is called, input bracket I equals single quote E, and go on from there. So if we want to just continue this example and break this down, so what are we doing? We're looping I over all the characters in our string, and I'm just going to print out character. I'll print out the value of I, and I'll say is, and I'll use a %c to print a single character, which is what argv bracket I is. If I did a %s, I would segfault really quickly. This is a single character. It's like a thing inside single quotation marks, and we can print it out with a %c. We could also print it out as an integer if we wanted. And we might get a compiler warning, but so if I say oops hello, ooh, look at that nasty warning. Ooh. This will take us into a good discussion tomorrow about char star star. argv bracket 1 is a string, it's an array. So that thing has, the ability to access each element by saying bracket I. So this is, closer to what you're doing in the ODP, where you've got a character array named, input, for example, if that's what you declare your input to be. But just for the sake of goofiness, right, since argv bracket 1 is a string, I can say argv bracket 1, that's a string or an array. Let's look at element I, and let's print that out, and print that out here. So there you go. So string length returns 5, character 0 is H, character 1 is E, and so on. And if I print those with a %d instead of a %c, what do I get? I get the ASCII codes for each of those characters. The ODP has nothing to do with argc, argv, because you're writing a function, right? So your goal is to write a function named count E. So for the thing that you're going to assess, there's no argc, argv anywhere in sight. I've been doing this with argc argv just because it was a seemingly convenient way to play around with strings. But we could do this. It's everything up to, but not including the null terminator. Alright, so this is probably a clearer example. Right, so temp is, this is a test, and here you can see the individual characters from 0 through the 14th character, and there's the ASCII codes for them. And I'm getting this warning, implicit declaration of built-in function string length. So you want to include string.h. And that's what prototypes functions like string length. And if you kind of mess this up, if you go less than or equal to string length, it claims that there's a character 14 which doesn't print as anything, which is 0. That's the null terminator. It's not technically considered part of the string, and it's certainly not going to be a letter E, so we're not going to count that in our count E function. And if you go kind of go a little overboard and just try to print, 1,000 characters from our array, well, we got, our this is a test space, and then we got temp is space, and we got a new line, and we got some funny things in here. And here's a character %d is %c. There's, and these things over here. And we're fishing through memory, right? We're still printing out elements of our array, but we're not actually in our array anymore. We're in the area of memory after where our array ended. And, if I did this out to 100,000, I would almost certainly segfault. But here's some stuff that was stored somewhere in memory when it was formulating our output. Right, and if I do this too far, I get out to character 2503, and then it segfaults. So that's a whole bunch of ideas on working with strings, telling how many things are in a string using string length, and then accessing individual elements.
I have a question.
Go for it.
I'm a little confused by the whole I concept about what's happening there.
Here?
Yeah.
You're indexing it, alright?
So I is a temporary variable, and let me put this back to something reasonable. Right? I is just a temporary variable. I could have declared integer I up here, but I'm declaring it inside my for loop. But I'm basically using this to iterate through the elements in the array. So, yeah, so, hello. So when I equals 0, it'll do that, and then 1, and so on. Does that make more sense?
Yeah, we're naming it I.
Okay, cool.
I have a question about the count function.
Yeah.
I'm trying to do it right now, and every time I go to compile it, it says my parameter name is omitted. I don't really know what that means.
Hard to say. It could be a number.
You forgot to name the variable when you set up the function. So it should be like the function name should be like int, which is what it returns. The function name, which is count e, and then in the parentheses you probably just have char star, or when it should be char star, then like some name.
Right. Yeah. So when you prototype, you do it as it says in the assignment. When you actually write your function, yeah, like the other person just said, say char star and then the name of a variable, no semicolon but a curly bracket and then your code. And that variable is, you know, the thing that you can use in your function to access the thing that you're trying to analyze. All right, cool. Send me an attendance ping on the way out, and we will leave it there for now. We'll talk a little more about characters tomorrow and strings, and then I'll talk about VI, and we'll do some VI gymnastics. All right, have a good one. I will catch you next time.
Bye-bye. See you later.
All right, you too.
See you later.